In some earlier off-screen pre-assembly, I discovered that it's easier to turn the studs and the nuts into a bolt. If you know that the mating hole thread is deep enough, this is a great way to save the old fumble finger factor when you've got a bunch of pieces going together. 24 of these little shorties, and there's a half a dozen different sizes here that will be done individually. If you are familiar with this model, you'll know that the stack height of the base doesn't allow for the flywheel to clear the surface that it's sitting on. So I made a display riser for it. This display riser will come off later because it actually gets in the way of timing the eccentrics. To mimic the look of the machine being bolted to the floor, the bolts that are actually holding the casting to the aluminum riser plate are finished off with some brass hex nuts. 4.5 millimeter brass hex nuts. I ran immediately to the sink and washed my hands after I touched them. Just kidding. I thought it was a nice cosmetic, an ornamental finish to the base. And one on each corner. Repeating the procedure from the previous step, I'm going to use a little bit longer stud this time, and these are the 6 studs that hold the second component in line to the cast iron base already mounted to the aluminum riser. Using blue Loctite to hold this all together. There is absolutely nothing critical about the alignment of this part, and if you drill the holes and the bolt pattern fairly close to the print, the bolt studs or the studs themselves will line everything up just fine. Next step in the process is the installation of the main bearings and the crankshaft. The small alignment pin in the center keeps the lower half of the center main bearing from sliding back and forth. And once again with the shorter studs that I did initially with the nuts already connected, I think you can see the benefit to having them in one piece. If there's any warpage whatsoever to the crankshaft or any misalignment of these particular bearings, when you torque these nuts down, you're going to feel it. So it's a really good idea to go easy on it, go sequential on it, and if you get a bind, well then unloosen that particular stud and try again. Make sure you have some end play. And when everything is tight and lines up, put the oil cups on. I understand putting some cotton or some type of fiber in the cup keeps the oil from wicking down into the bearing too fast. These are the connecting rods that will drive the crosshead. And those are the parts that I put the small flat on to aid in the anti-rotation of the bolt that's going through it. That worked out very well. There is a diagonal oil hole in these that goes down right adjacent to the head of the bolt. And these were actually drilled as mirror images of each other so that the wrist pin on these each faces outward. Right side faces right, left side faces left, and the oil holes are all on the same side for ease of access when you decide to oil this for maintenance. This piece also does not have any steps on the bearing cap itself, so if there is a misalignment, you could go front to rear, left to right, and there's a half a dozen different ways this could go bad. So this is another one of those components that you snug it up, rotate it, make sure everything's good before you torque it down. In this shot you can see the oil holes in the rod. That is a 1.5 millimeter or an 0.60 diameter hole, and that's drilled in there at about 22 degrees so that it intersects the center of the bore. A little bit of oil in the cups as we go, keep everything lubricated. You don't want any friction for the startup. This particular kit did come with graphite impregnated yarn, but I decided to go with Teflon valve packing that you can get at your local home center. It is really important not to go an uneven number of turns with this packing around that stem. Try to get this as even to a donut as you possibly can. When the nut comes down and compresses this, if there's more packing on one side than the other, it could influence and push that rod off center and cause a bind. Nice true donut's the only way to go. The gasket for the lower head does have a small index mark on it. You can see it right there between the two screws. That does have to line up with the port in the cylinder base. These two particular studs are extremely difficult to access when the part is assembled because they're under the feet of the standard. The other three holes, I'm going to use the originally prepared studs with the nuts on them. The trick that I like to use if I don't want a stud to migrate when I'm putting a nut on it is I will trap the stud itself with a very thin scale, drive the nut to the point where I like it, and remove the scale. A little bit of side pressure from the scale will keep that stud from migrating down into the cylinder and give you the desired result. Worked out very well. It's a good trick. In this step, I am going to assemble the standards onto the base, and I think you can see the advantage of aligning the wrist pins to the outside. Use 4 more of the pre-Loctited little bolt studs that I made in the earlier segment, and repeat for the other side. When you pre-build these assemblies, be sure to pay attention to the clocking of the steam ports. The bolt pattern on the heads is symmetrical top and bottom, and you can assemble this with the intake and exhaust ports reversed, and they won't line up at assembly. If they do line up at assembly, then the steam chests won't line up at assembly. So pay attention if you're going to prefab something like this. Just take a minute and visualize it. For ease of installation, I did the steam chest as a sub-assembly as well. And although one side of that clevis is threaded, you can still rotate that clevis if it's not connected to the eccentric strap. I used a little bit of Loctite on everything to make sure that it was going to stay put. And I'm not using that gauge block as a screwdriver. I'm using it as a stop point for the threaded rod that's coming through, so the top of the strap has room to operate. Using the same Teflon packing as I did on the other component, but I need to flatten this out because this is a smaller thread. And like I said once before, be sure that the packing is one complete loop or 2 complete loops, but being a complete loop is the most important, or it could push that rod off center under pressure. Now, admitting the only mistake I made on this particular build was the bolt pattern that you see right there for those 4 studs. They are actually supposed to be asymmetrical by approximately a 1/16 of an inch. The dimension on the drawing was very crowded. I looked right past it and I made that a square pattern. So I had to make additional notes throughout to make sure that all the mating components, the steam chest and the cover, also had the same square pattern. Watch out for that. The assembly of the eccentric strap is fairly straightforward, and I'm going to use the eccentric cams that I redesigned. The holes to secure the caps to the actual eccentric are right on center line, so it's easy to put them on backwards. I used a gauge pin to assure both sides were aligned and didn't pinch the crank at installation. The eccentric straps are installed with the cap screws facing out on both sides. But the oil holes do line up, so when you see the final assembly, the oil holes are both forward and the cap screws both face to the outside. This was done by design so that the cap screws were not close to hitting the base during rotation. All right, let's take a break from the assembly for just 1 second and take a look at the progress so far. Everything is getting there, but I had to take it off the assembly base that I had on there, the riser base. And, like many people have noted, the flywheel and the center and the thickness of the base and everything doesn't add up. So the flywheel will hit whatever surface you're sitting it on. That's why I made a display base for it, and that's why it's currently up on a piece of acrylic. Well, as far as the valve timing is concerned on something like this, initially I am scratching my head about, okay, I want to time it this way, and then I want to spin it around, and I want to do the exact same thing on this side, but wait a minute, maybe not. Maybe they have to be mirror images of each other. And I will, as I shoot this, have not figured that out, but I will figure it out. I'll probably lean on Mr. Keith Appleton for some words of wisdom on that, or a diagram somehow to know what's going on. One of the things that you absolutely have to understand is there's an awful lot going on here. The valve itself has an adjustment up here in the top. There's a threaded rod that you can adjust the slide back and forth. There you go. So you don't want the valve itself to crash into either end of the steam chest. There is an eccentric down here that controls when and where and how, and what they're saying is you want the max throw of the eccentric at 90 degrees to the crank. So you can see the crank throw on the inside right here where my finger is pointing straight up, and the max throw on the eccentric is 90 degrees to that. So one of those positions is top, and as it comes back around, we're now on the bottom. When this event occurs, you want the valve on the inside to just start to reveal the respective port that it is closest to. You want it to just start to open. I think that's so that you can get a little bit of an extra bump to push the piston out of the way or allow some of the gases in there to escape. That being said, once you have the valve timed accordingly so that it's in the middle of everything, and this is at 90 degrees, well, that's when you have to start messing with the eccentric here so that on the top and bottom, top dead center and bottom dead center, you get the desired peekaboo effect in here. Let's see if I can shoot a light in there and show what that is. There's one port on the top, and there's another port on the bottom. As this strokes around, you want it to look just a little like that. You can see I'm not going to cover the whole thing up. It's one of my dive lights, and it has a bad habit of washing the color off of things, so forgive me for that. This is extremely bright light. You want it to just reveal just a little bit like that, and the only way to do that is to mess with the cam timing. Right here at top dead center, we are just about closed. You can see a little in there. And at bottom center, that little joint. Nope. Bottom is not going to make it. That being said, the adjustment would have to be either the cam or the screw. Now, if you're going to substitute a screw like I did, make sure that the substitute screw that you use is a very fine thread, or you're going to lose the ability to get the finite adjustment that you want inside that steam chest. The grub screw on the flywheel was put in at an angle, so for ease of access, I positioned the screw to the outside, and it is engaging a flat on the crank. Once you have visually verified what you believe to be correct stroke and positioning of the cam for the valve, it's time to put another gasket on and seal it up. The upper and lower head gaskets both have the same little scallop notch, so make sure that when you line it up that scallop notch is over the notch in the head. Also make sure that the alignment diameter on the underside of the head engages the bore before you torque everything down. Knowing that I'm working with very restricted or limited space behind these steam pipes, I'm going to wrap some Scotch tape around my 6-inch scale and use that to position the nut prior to torquing it down. And I got to say to the people at Stuart or whoever made the piping kit, I did not solder those. The bolts didn't fit through the majority of the flanges, and all of those flange holes had to be re-drilled, every one of them. Make sure the gaskets are caulked correctly before torquing everything down. And make sure that all 4 bolts are in before you torque anything down for ease of alignment. An alternate feed port is provided to give you the option of positioning the pipe. I'm just going to use the one that goes in line with the pipe itself. All right, I don't know how steady this thing is going to be or not, so it is secured to the display plate, and the display plate is trapped in the vise where most of the pieces were made. There's going to be no perpetual motion hocus pocus going on here, but I am going to put this camera on a tripod in a second, and we're going to take a look at this thing run. I got to tell you, this was a heck of a project, and if I had any advice to give anybody that's going to tackle this project, is don't go overboard on the precision. The precision parts are the pistons and the bore, because there are no rings in this engine. This is a brass piston inside of a cast iron cylinder, and the fit is about 5/10,000ths of an inch clearance. So that's about the only thing that you really need to have super precision. If you start getting crazy with the distances between the webs and the thicknesses of these bearings down here, you may encounter some difficulty. I did go back in there and I did shave a couple of thousandths off the ends of the main journals to give myself some end play, because it was just about line contact, and I just didn't feel good about that. I did put a flat on the main crankshaft so that the grub screw, set screw from the flywheel had a place to register, and this is the first timing event per the instructions and per Mr. Keith Appleton. Thank you very much for your videos, sir. They have been quite helpful. As far as the top dead center timing of the piston is concerned, the valve inside the steam chest needs to just start to open as the piston reaches top dead center. So that's what I did, and in a minute here we're going to put some air to this thing and listen for the chug-a-chug. Here we go. I got to go handheld here for a second. I am absolutely smiling ear to ear right now, and I will probably sleep with a smile on my face tonight. This has been an amazing project. I absolutely can't thank Steve Bright enough for the gift of the opportunity to build this in the kit. That flywheel isn't running out at all. I am extremely pleased with that. I added oil cups to the main bearings. They said to put oil holes in it, but I like the cup. A little bit better reservoir. I'm just going to let this sit and chug for a second, but it is just perfectly quiet. I am thrilled. Love it. If I make any changes to this in the very near future, I may add brass heads and brass steam covers, maybe with my company logo or my initials on it. But for now, I'm going to leave it just like it is. I like the cast iron industrial look of it. I'm not going to paint it right away. And I want to thank everybody that has commented, tuned in, persevered through this extremely long series. I can't tell you how grateful I am. Thank you very much. I could just sit and watch that all day. That's all I got for you for today. Joe Pye, Advanced Innovations, chalking up another one. Thanks for hanging in. Stay well wherever you are in the world. I hope you are well and happy and safe and comfortable. Me, it's time to go. Joe Pye, I'm out.